Let's start our class. So today is our topic is static. It was in a previous lecture. I mean, do you have 2 lectures on static? Am I right? Okay. So, and today our quiz is about.
Oh.
You can do like this.
Good.
What again?
We predicted
Why?
from previous course and because one lecture
Gap.
we are late for one lecture.
But you
one
didn't
block.
take a quiz for resultant motion, so
Yes,
we
actually,
expected it to
yes.
have the resultant motion.
So about all quizzes in Moodle, I mean all grades. So today evening I am grading all of the existence home tasks what you uploaded. So also another announcement. I will close all submissions, research home task, all home task others after the midterm. So you're writing midterm, I close everything. So you have to finish all in this time. Yes. Probably so. We have our midterm consists of, let's see, actually next Tuesday, because today was the last lecture of statics, am I right? Tomorrow next time the last lab on statics, and after this, yes, you're making home task and you're doing next week.
So, like, if we partially submitted the assignments before, and will you check them? Or
You just need to say me, hey Alec, I redone it, or maybe I add something, and so on. So let's start. First, I'd like to say about, have you seen some kind of slides? No? Actually, there are 10 possible, let me say, we can map about 10 type of contact during our, actually not only about our, in general. And so on the left side, you can see what kind of type of contact, and there is the action what we are doing. So for instance, we have a cable, ideal cable, I think this, it's T. Smooth surface, just normal. It means there are no friction. Rough, we have friction, normal and so on. Actually, who have heard about cone of friction? We will study it on dynamics. Actually, it's the reason why I'm not explaining this. But you need to understand that in Gazebo, it's a simulator, robotic simulator. Every robotic simulator uses cone of friction in the inside of it. Because when you talk about friction, it's not about the one direction. Actually, it's more than that. It's in 3D. We can represent it using cone and angle. So what else? Roller support. Who can explain why there is only N?
Because the body, like the support can freely move in the X direction, but is restricted in the Y direction.
Yeah, exactly, because it can rotate, so no moment or torque. And you can move, yes, along X direction. Second one is almost the same. In this case, pin connection we widely meted, yes. It cannot move, it just fixed. In this case we have reaction force on X and Y and symbolization of them. What are we talking about? Fixed support, in this case we have everything. I'd like to ask you about 8th one, gravitational attraction. First of all, do you have a difference between center of, so how many center do we have in our body?
Center of mass,
Center of mass.
center of gravity.
Center of mass. What else?
Center of gravity.
Gravity.
Center of
Maybe geometrical.
Geometrical center. Yes.
vesicles.
So the question is following. First of all, is it the same or not?
Not always.
Who can explain? Who can
Depends on the
explain?
material and the distribution of the density of inside the material.
Mm.
Center of mass can be different from center of gravity if not all gravity forces are parallel, basically.
Mm.
Otherwise, they're the same.
Could you provide the example?
Well,
You can say.
I mean, if you have a object large enough that the gravity forces on its ends are not parallel, are actually they intersect.
Yes. Okay. Yes, you're right. I will show the example. But I'd like to ask, what the essence of the gravity, actual essence of the force? Is it? See, is it real? Let's see, force when we are drawing like this, or not?
Resultant force of the.
So when we talk about gravity force, is it? So actually, it's concentrated force called. How can we concentrate it? Because it's concentrated at one point. When we're talking about actually all forces in our life is not concentrated.
Yeah.
It's distributed.
Distributed.
Yes. It can be either on volume and either on area. What do you think about this? Could you provide example of one or another?
Area is like the reaction force of setting down on the.
Yes, we can actually, when we are doing like this, we can say that all my arm is some kind of area. What about volume?
Gravity is involved.
Yes, gravity is a volume. Actually, we can say that the real situation is we have a lot of forces and we are pushing them inside of it. So the answer is yes. They are, for classical mechanics, your center of gravity and center of mass are the same. If you want to look more, you can just stop on the slide. I mean this video. But I will provide the example. First of all, we need to understand that our Earth is not a sphere. It's helioid, if I'm not mistaken.
Ellipsoid вращение.
Not, it's look like ellipsoid. Okay, it's more complicated, if not mistaken, but doesn't matter. Ellipsoid, and the gravity there will be different from there. Let's assume that I'm making a very large bar or alloy, steel alloy, and the gravity for there and there will be different. For instance, theirs will be 9.5 and there 9.9. In real applications, I'm not mistaken, it is widely used in architecture because when you have a really large stadium and so on, they have to consider.
Well, it's constant G gonna be different.
Yes, because in our case, when we are talking about G equal to 9.8, we are talking about uniform distribution. Because we can neglect the, let's say, this is not uniform because for this point, it will be a really small difference. So we can use 9.8.
Okay.
Because we have force, it's boom, 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 from up to down to me, on full volume. And the volume, I mean, this force on this point and this point will be almost the same. But we are talking about the really large, we're talking about kilometers, not meters. In this case, we have to consider.
I just thought if I have a really long object, then the vector of the square is going to be different.
Vector also will be
but even the magnitude too?
magnitude, yes. Because,
If you're talking about
yes, because with sphere, it shouldn't be like this. But when we're talking about ellipsoid, the distance to the center, if not mistaken, the gravity constant is gravity R1, R2, divided by R square, something like this, and we can divided by R2 square probably, no?
R squared.
Yes. So we can take this gravity force somehow from this, but actually our R will be different from one point to another point.
Okay.
where do we need to know center of gravity or center of mass? What's the application? So you in robotics, try to think almost anything. So
Like, can we draw all forces from the center of gravity? Like,
okay. We will return to this question, but before I'd like to listen about
So, for applications,
yes, application. We're doing.
for robotic manipulators, it's important for me to understand where is the center of gravity. If I lift a heavy object, like where will the most torques will be because of the bending and so on.
Okay, when calculating dynamics, we can say like this, because we need to find inertia. Inertia is related to center of mass. Okay, what else? Michael, what do you think?
We can stability.
What again?
When we want to calculate put the object is stable, and it needs to be of what standing on one and
What did you say? Oh, what did you?
We can find any forces balance in object or robotic.
Actually, yes. You are more. I mean, you're almost saying the same thing. It's ZMP, zero moment position. Actually, when we're talking about our robots, quadruped robots, or just humanoid-like robots, we can say that we have three types of gates. Not gates, actually not gates. Let's see, movement. We may say that we have static gates. So it means that in each point of time, we can, like this. In each stop of time, I can stop, and I can easily, in this case, for instance, I can use ZMP. How it works? So we are calculating the center of mass of our, let's say, robot, and it shouldn't be in. So we have area below this, and we shouldn't, let's say, go through this. In this case, it works. Yes. Actually, we can check it. So I change my center of gravity, and I stop the fall.
Center of mass, center of gravity.
In our case, as we discussed, it's the same. We can, yes, because we are working in classical mechanics. What about when I talk about Atlas? These fancy robots, they not using a static way. They're moving dynamically. Is the reason why I can roll, they can make flips and so on. It's very complicated. You need to solve a lot of quite complete nonlinear equations. So it would put a challenge both for hardware and software too. How to find this? Actually, if you are in linear algebra, you need to remember that you can using calculus problem. You can try to use integrals and find center of mass. In real life, you just need to take fusion or whatever, click on it, and you will find the solution. If you didn't know how to do it, I can just do it on the fly. It's not a big problem. You just need to shoot. What again?
Do it, please.
Okay. So I will activate fusion while it's activating.
So do we need center of gravity near Earth?
You can. So we're talking about the center of mass. We're talking.
This is another question. Do we need to know the center of gravity near the Earth's surface? Like, we are not constructing such big things.
Yes.
Because we are robotics.
Yes.
So do we need to know?
No. Actually, for our purpose, it's just to extend your horizons. That for our purpose, we just can say that center of mass and center of gravity are the same. That's it.
Okay.
If some nerds ask you, I disagree with you, you can say, okay, I'll explain you. So in this case, that's it.
Okay.
Let's do it. Okay. So while it's activating, I'd like to ask you a bit other things about statics. Okay. So first of all, when we're talking about statics, about one body on a plane, how many variables can we find?
What do you mean by that?
Free, yes. Any free or not? On the force, maybe on the torques.
Any free.
Usually it's reactions, but anything.
Okay, any.
As long as they're independent.
What again?
As long as they're independent.
Yeah, guys.
Independent free variables. Yes, if I
Yeah.
make one depend on other, of course I can make
Yeah. So
like this. Okay, Q, so the row 1 equal to row 2 or 3.
3 variables.
Makes it. Okay, dependent. Nice comment. Plane 3. What about the in 3D?
Nice.
Yes. Because we can make 3 equations of positions and 3 equations of torques.
Mm-hmm.
So the question is following. Can we find, so we have a chair. Can we find the direction force of the leg chairs?
Direction force of what?
Reaction.
Reaction. So we have chair. I want to find reaction force for, so it stays the ground, am I right?
Mm-hmm.
Can I find the reaction force of it?
Yes.
Yes.
Are you sure?
No. But we can try.
If the chair is absolutely symmetric, then yes.
Actually, let's say, in this case, you're assuming this. But in real life, we cannot assume this.
In some particular cases,
And why we cannot do
I
it?
don't know.
So why we cannot find, let's say, a reaction force for the chair?
Not in our calculations. Because
We have 4 legs. 1, 2, 3, 4. 4 reaction forces. We cannot find it. Using static methods, we cannot find this. We can easily find it using other methods. For instance, we will learn some of them on strength of material for the next semester, and mechanics and machines. But right now, we cannot find it.
But we can find 6 variables.
But actually, we are talking in 2D in this case, because we have a plane. Our forces distributed on a plane. It's not in 3D.
So if we have a stool, we can, like a stool with 3 legs.
Yes, we can.
Okay.
In 4, no. So, where is my fusion? Pam pam pam. What's the?
Yeah, on the fly.
Okay. I see. No internet. I got it. Where's my internet? I got it.
Every time you want to show someone.
Bam bam bam. And yeah, hooray. So fusion on the fly. I say.
Hey, just
Second time.
open fusion.
Fusion is never on the fly.
Okay. Not complaining about fusion. We will use it on next semester. So blah blah or maintenance.
One more question, because the chairs thing is interesting for me. So if the chair is symmetric, as Andrei said, we can calculate it even if it has like 4 legs.
Because
Because
some of
we
the
know-
variables become dependent.
So we can make like a force equation that's saying that.
Yeah,
Yeah,
That's
just
one
you
of the
assuming
forces.
that reaction force 1 equal to reaction force 2
Uh-huh.
equal to this, yes.
Okay.
But in general, you cannot solve this equation.
We can make like chair symmetric by ourselves. Spin could be
First of all, we can say that our ground is not symmetric.
Well, it's
Our reality is not symmetric.
Yeah, hooray.
когда система что-то не инерциальная получается.
Correct? Correct? Okay.
It's all
Yes, we
by
can.
the way.
Okay, oh, hooray, fusion is free. So, I just opened any, I don't know. If I'm not mistaken, it was done by Ahmed.
Yeah.
Yes. It will be your next, how to say, semester coursework.
Mm-hmm.
Not this, but okay. So, okay.
Beautiful.
Yes. It's not from him, but okay. So, in this case, I can choose any. So, I took one, let's say,
Does he eat people?
I can say properties.
Lots. So
Yes, and I can took physical parameters. mass, density, center of mass. I can find this point, center of mass, and I choose just okay, MIGI, bam, and you can find the point should be where it is.
Just hide everything else.
Okay.
So the analysis. Analysis is hidden. The analysis folder is hidden.
Ah. Well, yeah. So you can see this. I can choose any point. I mean any. Let's say either detail, even the complex of details, and I can find the center of mass.
How does it?
It doesn't.
You need to rotate. Yes. It's not. Let's say it's not connected. Yes. So just to show you, you can do.
It's done in SolidWorks or?
No. Actually,
Because
this one.
I think it's
Probably it's
SolidWorks.
yes. I took it from step file. Yes,
Yeah.
but in. Okay. So to sum up, we can when we talk about plane, we are talking about plane right now. We can find on the free, say, variables. Why it's helpful for you? Because in this case you can understand. Can you solve this task or not? Or probably you forget something or you didn't recognize. From that. Now we are having new, let's say, formal criteria. They are on the stage. Because we are stepping on dynamics like, say, area. So we are trying to solve this guy. First of all, about hints. As usual, because I'm preparing hints for you that might help you to solve other tasks. About plane we discussed, about space also. We can write, can we divide this body onto parts? And probably will receive more equations, no? Yes.
Yes.
In this case I can avoid such limitation. It's one body. I divide on two and try to solve this equation, this equation.
Is this two rigid bodies?
No, it's one rigid body.
What is happening?
So I have this, so you have both. We have, so it's one rigid body like this. We have angular momentum. We have some force. And we have distributed force there.
We assume the mass is negligible. Mass of the body.
So actually you can divide and try to, you may write equation for whole body. Yes, I can divide, take point, I don't know, n. So in this case I need to say that I have new forces and new torques, but actually it won't help you because they are dependent to each other. So we can divide, but it won't help you.
So not introduce more equations.
Yes, we will have more equations, but they are useless. Okay. So force. Yeah. Force is interaction between the bodies. I hope you remember this from the definition of force. What else? About point of force. It was probably your question or somebody else said about.
Zafar said if we have center of mass, can we use it as a center of forces?
When we are talking about force, we are talking about rigid bodies. I have some force probably to this point. Can I change the application of this force? Change the point application.
You can move along the line.
Yes, like that, like this. So we can be there. What about torque?
Torque is quasi-vector.
Yes, and
So it does not have a position.
we
Certain
can put it in
position.
any place. So we can say the torque is there or torque is there. Place. Okay.
Mm.
Next question is about. So, did you understand why we can move along the axis? Who didn't get? I can show an example. Давай. Okay. When I talking about rigid body, I put it there, and I try to push on this point, or take this, it will be the same for us because it won't bend. If I take, for instance, this cup, and I will force there, or I will force there, it will be different forces. In theoretical mechanics, we are working only with rigid bodies. When we come to the mechanics and machines, we will work with not rigid bodies. In this case, you have to think only in terms of points. Okay, so else point force should be yes, direction for blah blah. Okay, we usually find force or reactions there, not forces. Other hints, because as for me, you can try to correlate between velocities and velocities and accelerations and forces torques. How? That actually it's about mass apparatus mainly. The angular the torque looks like 1 by omega. Why? Because if you remember on angle, so we have different story there.
It should be. No, вроде. In lecture slides we have radius times force in torque.
Let's check. Yeah, you're right. Thanks. When we talk about forces, it's almost the same as velocities. You can find a correlation between forces and velocities. What I'm talking about, in linear velocity we can we can find angular velocity with them, with these equations. In the force and torques we also can do the same. So as for me, you can just, actually it's appeared, you already studied electrostatics and mechanics. Did you find anything?
Similar?
Yes.
Like friction force is kind of resistance.
Well, actually, when we are talking about equations, for instance, we have rotation, linear velocity, and so on. Inertias. Actually, it's better to. I cannot provide the example right now, but you need to understand that Simulink, in MATLAB, in my Bauman State University, I had some, let's say, tools. You can use the same blocks. They will have the same, L, so M, and so on. But you can, using the same equations, explain mechanics and electric.
Oh,
stuff.
yeah.
You have completely the same math apparatus. You need to understand that a lot of equations look similar for different domains. It's quite important. About distribution forces. in like do you remember the equation? What will be the Q?
Q times A.
Yes. We won't derive it, just to accept it.
Mhm.
We will work with this more on the astonishing material. In this case, what will be there?
Q value over 2.
Это Q. It's our just prerequisites. We're preparing equations, formulas, we know everything, now we can solve tasks. So again, find reaction forces of this guy. Okay. There is no red.
This.
Here.
This.
Now we are starting from research object. I will write it in. You can error all. How many bodies we have? One. One rigid body. You can write beam, for instance. Body was fixed because it's the reason why I'm trying to solve statics. It's the reason why we have we need to understand where do we have our reaction forces. In our case, it will be so our body fixed there. It means that we have Ry, Rx, and Ma. Can we write like this right now?
Yes.
No, because we didn't put frame. We need to say where is our frame position. So it will be there. X, Y. In this case, yes, we are correct because whatever else. Okay. What else? We can say that we need to write point A fixed. Because of this is fixed, we need to find Rx, Ry, Ma. For A, I already know that I can find only three variables. Okay. So we understood what's going on there. Now we are going to the force analysis. So for A, we don't know Rxa, Rya, Ma. What do we know? We know P. Did we learn, let's say, Lemur rule, if not mistaken, or something like this? It should be on the lab.
Varignon's theory.
What's it? What about? I mean,
Like we can expand moment of some forces on sum of moments.
and about force. So actually, we can say that we have this force. We can, let's say, put it on the basis, find projections, or we can use this fancy word Lemur. I forgot how it's called. Some theory. They say the same. So we can say that P on so Px will be p cosine alpha, because we already know that's 45 degree. In py, it will be minus p sine alpha, because our system coordinates looks up. Q, we already know it, but it's distributed force. Let's put it there. We also need to put it there. Do we need to know length when we are solving these tasks? Yes. Let's call it PQ and AP. We know them. Now we need to write solutions. So for x, we have 3x plus FQ plus Rx equal to 0. What do we know? We know this direction and magnitude, we know the same. So Rx y will be y plus y equal to 0. Because we're just looking, okay, p there, ry there. And the last one, moment. When we are talking about moments, we need to choose the point which we are using for solving this task. Let's choose moment around point A. It will be, I hope you remember that counterclockwise is positive. Moment is negative. Minus m minus 2py is look like this, so it is clockwise. What do we have else? Do we have Rx or y there? We don't have Rx and y because at this point we don't have any moments of this this force.
Oh, sorry. Where does 2py came from?
2 is the length.
2 is length first.
Oh, yeah,
yes,
okay,
my
and
bad.
py.
Yeah. Because I worked with non-digits first. Okay. it will be
PYPX?
AP. Yes. Why this? Because, as you remember, we can put it along the axis. Our force axis is there. We can put it there and can solve.
Okay.
Rotation is positive because it moves in this direction. And plus MA. Okay. Equal to 0. So we know this guy, we know this guy, we know this guy. MA. For A we solve the task. So, as for me, it's the main difference between physics and theoretical mechanics. Because in physics you just try to solve the task. In this case, you using this methodology, because research objects, you understand what's going on there. You need to explain why using such algorithms. Body was fixed, and you're explaining where it was fixed. Because when you're writing like this, I can understand. For instance, we will have also we fix this point. So we have 2 points, A and for instance K or P. We call it P. Yes. P. If it fixed, we also have Rx, Y, and P. I have 6 variables. I cannot solve this task. So I can also solve this task, that's it. My work is done. Actually, it really helped me to check the task from previous batch on exam or midterm, because if you didn't write this correctly, I don't even need to read everything else, because it means that you didn't get with grade 1 there. It means that you failed, even in the beginning. And if you write it correctly, most of the, you have more than half of the solution already. After the force analysis, when we have dynamics, in this case we will have kinematic analysis also. In this case we are explaining what we have. We can also expand something like P, we can expand there as Px, Py, because it's just, for me it's easier. You can do it like, we have distributed force, we can make it consolidated because we know how to work with this. We don't know something. We also can see that how many variables do we have, we don't have. And we just solve the task. So what about, for instance, let's discuss about B and C. We won't solve it, but let's discuss what, this part. Because probably for you, this looks weird. What is it? What is it? I will explain in the notation.
We know what they do. Similar reaction.
You already covered it.
Yeah.
So could you?
All the reaction, all major reaction types.
Okay, could you see what will be the point B then?
The point B there, that's a rod connection.
What again?
Rod connection.
Okay.
Rod constraint.
Yes. Okay. So B rod, and what does it mean for us? What do we find in rod?
And also A is.
So what we need to find in B?
Reaction. Just the reaction magnitude because I know the direction.
Reaction of what? Which direction?
The reaction in the rod constraint is always along the rod.
Okay.
From the first connection to the second connection.
Alright. So it's ideal beam. So we cannot stretch, cannot twist, it can rotate. So we don't have moment. Because we cannot squeeze it, so it means that we have on this direction. Because it can rotate, rotate.
And there was also the A is like a sliding.
And sliding, okay.
Connection.
Mm-hmm.
That's two reactions, a moment and one vertical reaction. So R1.
Say, could you try the last one?
I don't understand what is going on with point A. I've been thinking about it for the
Let's
last
start
5
from the
minutes.
point.
It
It
should-
might help you because if you understand that you have, in this task you can understand that it's correct task and you can find it. Okay.
So for point B, if we start from point B, we have a rotation, and it has one.
Pin or rotation joint, okay.
Yeah. So it has like one reaction, but we can like put it into two, like Rx and Ry. And is it sliding? I don't understand like the drawing itself. Sliding.
So it's looks like this, right?
Yeah, but there
So
is
it
like
slides.
sliding up and down also, right? So it's like 4 sliders.
Only
Yes.
torque.
Only torque because we cannot bend it.
Okay. So it doesn't move up and down because of
Yes.
this slider and this slider.
Yes.
Left. Okay.
So A, we
So
can
it
call
is
that
like-
what also
As I understand the A connection, it can move up and down, right and left, so the XY is completely set, it just doesn't rotate.
Yeah, so we can say 2 sliders.
Mhm.
2 sliders. I called like this, I don't know how it's called officially. And MA.
Okay.
Everything is clear? Okay. So far so good. Let's go to your tasks. Nabil, do you want to try to solve in the whiteboard?
So we need to center product. So we will have to.
The hinge mean only this range or
No, the rod is hinged by 60 degrees. It means A. Yeah.
So 60 degrees.
I mean what he wants to
So what we are doing first?
calculate the R of
We need to draw the picture. And choose the coordinate system.
What does it mean? 3 3
It's no, it's not a typo.
That's just the weight.
Kilogram force. Kilogram
Yes.
force.
Yeah. Without G. Don't worry about G. just
Yeah, that's
use
cool.
force.
That's convenient.
Kilogram force for us. I mean, it's not Newton. It's 1 divided by. I mean, it's something divided by something. Newton's okay.
Basically,
It's old school notation, you know.
it has a weight of 2 kilograms. A
Yeah.
weight of a body that has 2 kilograms.
While you're drawing, I will Google. Kilogram force.
Like weight is a force.
Weight is a force. Has 2 kilogram force. Yes.
So it's
It's
2
not
force
weight,
force.
It's not mass. You're not given mass,
Okay,
you're given the weight.
So
His weight is a weight of an object that has 2 kilogram mass.
Okay.
So basically divide by G.
So 1 kilogram force equal to almost 10 newtons. So, okay, you draw the picture.
First things first, for connection.
نفس اللي انا قايلها كده بالمحاضرة.
So, we draw the picture. What do we need to do next? Choose the coordinate frame. It's better to draw it in the picture because we have nothing to take from it. Okay. Great.
I can't remember the action of this hinge, but it moves,
Yes.
right? So we don't have momentum, but we have
So first we need to understand how many bodies do we have there.
how many what?
Bodies?
Not reduction? Bodies or bodies?
Bodies.
Body.
Body.
How many rigid bodies do
How
we
many
have?
rigid bodies do we have there?
We have this rigid body and we have a rope.
Rope is not a rigid body.
But it can stand.
It's just a constraint.
It's
It has
rope
only
is like-
tension.
Rope.
It's not a rigid body because it can.
So, could you write as we need? The search object.
Or object.
To read RO. One rigid body. Okay,
We need to find the direction and then the forces.
so we need to find actual interaction.
I mean, I should do the reactions first and then the
You need to understand, so it's fixed and we need to write, let's say, what do we have there? On point A, it will be rotating.
only rotating, so we have R is and Y.
Yes, and there you can use different color.
So the different color is not like
It's not help.
Black.
We have. Does it also have actions
No.
you have only one object.
You rule that you have, yes, only one object. So you need to write, so okay, so first of all you need to write down, you have, yes, point A. So it fixed, this point, this, what's it, what is fixed, is the reason why we can say yes, A is, it's, because it's spin or rotational joint. Wait, so rotational joint. If I don't find this research open and blah 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 in your quizzes, midterms and so on, 40% of decrease your score. Because it's quite important, it's crucial this course, crucial part of this course. Rotational joint, Rx, Ry. Okay, now we're doing about force analysis.
There's also substitute.
Okay, so we need to write that liquid weight. You can write rail, okay, it's not very well. Can we do something with this T?
We can find it.
So, so can it be helpful for us? Probably yes, because we have yes. So you can write there yes T. Do we need this point? Do we need this point? Point C.
Those are that the angles are wrong.
Actually, first of all, let's discuss. Do we need this point C? Is it helpful for us? What can we take from this? Is it applicable to our body or not? Already. So it has some forces. You wrote T tension. Is it applicable to our AB or not? I mean, so we already put T there. Do we need this point at all? So why is it confusing? So you wrote research object one body. Do you agree? So when we talk about bodies, and we work, so when we write an equation, so our equation is related to what? To the body. Do we need any other? So you said that our research works only this body, AB. Do you need to know anything else about other bodies? Do you know that we have Earth there somewhere else? Probably I somehow, probably I am new to this task and I also interact with it. You say that you should go in this one. You already put external force from point C there. So do you agree that it's an force? So this rho, this is an force. So to sum up, we don't need to initiate rho. We can forget about it. It can help us on the in terms of angles. But right now, do you need this angle? Probably not.
So it will not add any more meaning, right?
What?
If I added it and consider it as a system, it will not add any meaning because we already have C here.
Yes.
It's called values are evaluation. You are already provided all the constraints and you only look at the flow.
So I think that's all unfortunately.
Okay, so you know that there is no Rx or Y. And also we need to find angle.
Basically, we can find our x or y and then find the total magnitude and then the
RAC.
from there.
Yes. If you find X and Y, it's just a projection. Yes. How many questions can we write?
And go. So one is
Okay, let's write two equations.
no.
We don't know it's
Also, you check the projections of T, please. And your angles as well. I'll leave it.
either cosine 30.
Или,
Yes.
правильно понимаю, то есть у нас есть угол 60, угол 30, и видите, что этот весь угол должен быть 90. А, С, Б.
Это угол 60 это ответ. Его нету. Он
Окей. Ну, даже если так, все
А, не, он известен сейчас, вот 60. Нет, он известен, да.
Да, ну тогда 90 должен быть угол.
Откуда 90?
60 то есть.
Так у тебя же относительно канатика.
Да.
Одно у тебя относительно канатика, другое у тебя относительно этого.
Угу.
У тебя разные углы.
Геометрию вспоминали.
Я не могу сказать. So, first of all, you had a mistake with... could you... Oh, let's find this angle. So we have T, according to this. This 30.
Что-то запутался. А, 60 будет в этой области.
So you need to find
А, нет,
this
да,
dash.
60.
This 60.
А,
And you can write
Ну, тут
sin
С.
30 or cosine 30.
У тебя внешний угол 60.
Какой?
Because
У
sin
тебя
to this
B, А вниз 60. Это внешний угол для АЦ.
we told about
30.
also big y-axis there.
Какой внешний?
Right?
Что значит внешний угол?
And now we're trying to find
Другой
the
раз.
y-axis.
Внешний угол равен сумме вот этих двух углов.
Let's again.
Это
Okay. Right. What's it? What did you try to find out?
Еще по-другому можно. У тебя BAC 120.
Y.
Сумма
Y.
углов ABCD 180. 120 плюс 30 это 150, 130. Абсолютно та же самая тема.
We have T there.
Подожди,
And we
почему?
want to
Быстро
solve
разговаривай или что?
like this.
Я вообще не понимаю, как нашел угол BAC.
And so we have to lose it.
80 минус 60.
Minus
B.
minus t
So the
cosine.
code
С.
guy there.
То есть меньше из B. А, все, вижу.
60 degrees. Yes,
Всё
60
нашел.
sine. Oh,
Окей.
yes. Yes, it's right
Человек
now.
просто слишком
Sine,
много
sine
интегралов читал, он уже забыл, что это. We can solve the Lagrange equation, but finding the angles.
Что-то вы выглядите у нас в школе.
до сих пор. Вы говорили, что он теперь экономика баланса.
So should I put them around 8, right?
So you have to. So can we find something there? Okay, you have two equations. How many variables do we have?
So,
We need to do
third
something.
equation.
Yes. What do we know also? It can rotate, am I right? If it can rotate, in this case, we can talk about angle or something. Now we considered on the linear part. Okay. So first of all, you need to choose a point.
Choose 8.
Why?
Because it rotates around 8.
Okay, guys. Why can so why we are choosing a point?
Because we need to find t.
Except I'd like to listen other. Actually, it's not really correct. It's not the reason why we choose. I can choose any point and it won't be a problem. Галерка. Сейчас светит. What do you think?
Actually, I can choose 8 to cancel this one. Because there is no difference between.
Yes, exactly.
So I
We are
can
choosing
cancel
this
it.
point because we have two variables rx and ry, and we want to simplify our equations. If we're choosing point A, in this case, we don't need to consider angular torques from Rx and Ry because it's equal to 0. So you need to write M and from around the point. You need to explain. So actually, I just wrote two equations, but I cannot understand what the point of rotation. I mean, for instance, for torque. Remember, I wrote X, two dots, and after this something. It helps me to understand what trying to do. Because when I look at this, I can understand, okay, you're trying to put on y-axis and you had a mistake with sine to sine. Yes, when we are using this kind of notation, we spend much more time than we just try to solve. But it helps you to understand where you make a mistake, and helps me to check it faster. So,
Знаем длину ОБ?
yeah.
Do you know this length or you don't know?
Она не нужна, да?
Do you think that we need it?
You don't need the length of AB.
Try to write the equation you will get. Потому что он у тебя поделится. Ты запиши уравнение момента.
Там не важно.
Сократится, что ли?
Можно не сила оставаться, не момент, а соотношение сил.
Да, точно.
It's for okay. But why did you choose AC?
Because the center of mass is in the middle of the.
You put C because you have C and rho. Okay. So what is between AC? It's AB divided by 2.
Yes.
AB. second T. You already found the T. So, actually, when we talk about rotation, you don't need to.
You mean I can just multiply by this one? Right? I think I can't do this because it's angle, so.
It's angle, you're right, but I mean, you can use different methods to understand the point. Actually, because you have force, you can move it somewhere in the center point from there. So, rotation is based on this point, like this. So you need to take a projection on this. Because it should be the closest distance, yes, like this. It will be different in there.
So it will be
So how many equations are variables?
so on this one I can get T.
So for variables, three equations. Great. So how to find angle? I hope it's not a big problem because you know AC. It's just this line, and R you can find because you know Rx and Ry, and you can just take as a vector and find the dot product.
He wants the angle of.
So it should be like this, yes. And after this, you can make a dot product because you can rewrite it with a vector. That is equal to. Using tangent, yes, actually. You can do like this or yes. I just explained the product to yesterday. It's the reason why I remember that you can do like this. And the second vector, yes, it will be y, or 1, and you can find the product cosine alpha.
Why we can find it then?
Yeah, you can find
Because
it.
you can.
Yes, because I can.
Use my method.
Did you get it also?
I was just confused by the directions.
Yes, I know, it's a tricky moment. Many people try to solve this puzzle, trying to consider this point.
That's why
When
in
can
the
I-
lecture there's like a whole slide about how you isolate the body from the.
I think that's in the
It's not today, it's previous lecture.
I don't remember it actually. So can I, when I can experience this?
So you say you go to search object is something, this one. What does it mean for us? That we consider only forces applied to this guy.
I can.
So when we talk about force, what is it? It's interaction between bodies. So we have this body, it interacts with this. What the external force? Yes, this T, we can say it's the same T there. So you already put it there. What else? Reaction, it's inside this body. What else? Weight, it's also external from the earth. So actually already consider this point. Guys, everybody get why we dropping, not including this C in our equations.
Yes.
Because it's also very crucial and you won't solve many tasks. Okay, thanks. We need the last volunteer. Mirna, do you want? Oh, before this, could you sit down? Could you sit? I will small video, and after this we will solve. I found the application for theoretical mechanics. No.
So we're creating at BYU are the developable mechanisms that make it possible to make complex machines that integrate onto surfaces to be very compact, but now can deploy and do complex things.
A developable mechanism can reside in a curved surface. So it's kind of hidden in there. And then when I actuate, boom, it comes out of the surface. So one example might be things that reside on Iron Man's suit. For instance, on his arm, there's some kind of covering there. That's a developable surface. And if there's a mechanism that comes out of that, does something cool, comes back in, that's a developable mechanism.
So there are a lot of industries that this can apply to. One of which is surgical equipment. If this was to scale, it would be a small, minimally invasive surgical device. And as it goes in, you have two different components that will unfold off of it, one of which could be a camera or a light, which still leaves this center tube hollow for a different device, such as these forceps, to now come in and do the operation.
This technology shows the most promise in the medical industry and the space industry. But for the space industry, you want it to be compact for launch, and then once it gets into space, it can deploy. This may be a rocket or a missile and have this fairly complex mechanism that just morphs and transforms off of that surface. Here's a wheel that's rolling on, say, a Mars rover. We hit some obstacle, we deploy that, it becomes a crawling mechanism that can crawl over those obstacles. We're also beginning to look at things like deployable drones.
So I want to have the drone be nice and compact when I carry it around. So what's fun here is it's deployed, right, and it can go back into the surface.
We were doing work in origami-based engineering, and as part of that we moved into curved fold. The mathematics revealed we can implant machines on there that will have these complex functions and morph out of those surfaces.
We usually design the mechanism independent of its home. So the idea of using a curved surface as the kind of home for a mechanism, that's revolutionary because we don't tend to think about mechanisms in this way.
Suddenly we could do really complex things that no one's ever been able to do before.
So you can use that kind of device. I mean, actually, now we are working on plane. You need to find kinematics on the plane. It's on about surface and so on. What the task do you prefer, this or this one?
Difference? Why the difference between this picture and this picture?
What do you prefer? Choose your fate.
I don't see the difference.
Choose the third one.
Very.
That's text.
Actually, you can rotate the tape. You can flip, yes.
Никуда рассчитал.
Didn't use the very fundamental equation for that. Considering this is a smooth surface, right? A and B. Doesn't say anything about friction. Wait, is it 4 meters long or 3.5? 3.5? Okay, so this is 0.5 and this is 3.5. all this A, this is A. Okay. We have this is surfaces.
Why we are not having moment reaction? Why we are not having a moment reaction there?
This is just smooth surface, it doesn't have moment reactions.
Okay, also you can try to rotate it in different direction, not in this way, but in this way, and it can rotate.
It can rotate.
Yes.
Yeah. So constraints, let's say we have A, B, smooth surface. We have balance. We have forces. So the constraints are forces. We have like to see. Also, let's choose a coordinate system real quick. I mean, there's no horizontal forces, so there's just y and x, but we're probably not going to be using that. Forces P, vertical down, right. So we have RA, RB, reacting forces. Forces, and we have weights. Of CB. We need to find the reactions of this order points of the inclusion. And that's it. Okay. So we have. So the projection on point X is useless because all our forces will be zero, so it's wasted. So it's just 0 equals 0 on X. On Y, we have minus P minus W plus RA minus RB. That's a big load on RA. Then we have torques. We'll probably need only 2 or 1. Okay. Let's say around point B, then we'll mark that up part B, we'll on RA. Point B. RA times A plus minus A times A, which is 0.5 meters. It's called counterclockwise.
Are you sure the direction?
Of the reaction forces?
No, of, let's say.
I'm just taking this as clockwise.
Did you have minus? Yes, you have minus. I didn't see that. You wrote,
minus.
Yeah, okay. It's so now it's correct. Sure.
What are the comical flags? So this one will be. This is the middle of the row, so it's basically alpha, say, over 2 or 2 meters. Obviously, that's not only and this is speed, just speed.
So we have two equations to variables. You will solve the task. Congrats.
А решать?
So he already solved.
А как же система?
You cannot solve two system of linear equations?
I can.
So
But not solved.
if you like it, you may go to the...
No.
Probably, maybe it's not a very nice way to solve the task, but as for me, if you already received all needed equations, if you have answer and when you are doing it at home, first time, so actually probably I don't know how to explain to the students, because now I need to explain to the first year bachelors that my my classes look like that. Now we are training strategies at home, I mean during the class. And after this, it seems that it's better to spend 1.5 hour, for instance, to solve this task from the start to the beginning using numbers, because when you have numbers, it's more feasible for you to understand that you're correct, you did it correctly. But you have to do it at home, because right now we can solve more tasks in smaller amount of time. We can, look at more tasks. If you try to solve from the beginning to the end, in this case, we can solve only about 1-2 tasks at max. What do you think? How can I explain to the first year bachelors? Oh, you were first year bachelors, actually.
Эффект Городецкий.
He just think and solve most of the tasks.
No, it's like we have participation points, so he takes some guys from class and they solve on the
We have
task.
like a big board, and we have like 3 people solving at the same time.
The same task.
No, different tasks.
Okay,
Then-
distributed system. Okay.
And then we discuss the solution.
Okay, what do you think about my way of teaching?
I don't know. I don't think we need to, like, as for us, that's good. As for first year bachelors, they need practice. At least.
Sometimes, my opinion is sometimes people need to see the whole solution. So maybe try it on one task, like show them how the full solution goes, and for like next tasks, you tell them like you reach this point, and you say you just do as we did in the first task and continue. Just like give one example and continue as usual.
What about the way of teaching that usually I have your task and my tasks? What do you think about this? Is it good way or not?
So for us, you solve it all without like finishing from start to finish. You just like arrive to one point and you say like this is done. For them, what I mean is for your task, you can say at this point we have to solve 2 equations in 2 variables, and we do it like this, because some people don't know. Like
Okay.
in first year.
So do you think that I need to solve it till the end?
At least
One
just
time.
one.
Oh, okay.
There's
And
one task that is like very quick to solve anyway.
Yeah.
Mm-hmm.
And after that, you can tell them like you can reach this point and practice it at home or something.
Okay, I can open MATLAB for the equations. Okay, I solved. Okay, they won't get it.
But actually, in a way, it's better than ours in first year, because in the first year, most of the PAs didn't see anything. Just open the assignment and tell us to go for it. And it was a problem for me.
Mm-hmm.
Usually, I like this slide because he didn't solve much, but he asked people to solve and explain them, and if nobody knows how to do it, then he will do it himself.
Mm-hmm. Okay, so for today is end. See you next time.